Welcome back. So we'll be continuing with the NumPy arrays in this lecture also. Okay. So we already saw how to print the elements in NumPy array, but suppose we need to slice the array. Okay, we had already seen how to do slicing in the case of list. We'll be doing the same thing, or the idea and the procedure is the same when it comes to NumPy array also. Okay, so suppose we have a list, or yeah, we will first have a list. So that's 3 by 4 list. Okay, we have 3 rows and 4 columns. So um, from this list we are creating a numpy array. So we just call the function np.array and then lst. Okay, so that's the list. So that numpy array will be stored in the variable a. And now remember, if you remember, there was a function array underscore p which we had defined in the previous lecture, in lecture number 8. Okay, so that's just for printing the array. Okay, so here we are just printing the array just to see the elements how they are arranged, and then yeah, then actually we will first print it and then we'll see line by line. Okay, so here, yeah, so this is our array. So 1 2 3 4 5 6 7 8 9 10 11 12. So we have 3 rows and 4 columns. Okay, and now um, let's do something. So what we are doing here is we are writing a new variable b equal to a and then 0 comma colon. Okay, so what it does is it takes the first row. So because the row index is 0, so that indicates the first row, and then all the columns. Okay, that's why we put colon there. So we are taking all the columns from the array A, and then we are giving that to B. Okay, and here I'm just printing the shape of B to see how the number of rows and number of columns are there in B, and I'm also printing the first element inside B. Okay, so B0 returns the first element. So I'll just print it and see. So yeah, here it printed first row, all columns, and then we are printing the whole array B itself. Okay, so 1 2 3 4. So we saw that it took the first row, whole columns, or all columns. Okay, the complete first row is taken. Okay, and the shape will be 4 comma. Okay, because that shape function always return a tuple, and if it's a single value also it will be returned as a tuple only. Okay, so that's why there is 4 comma nothing. Okay, and then the first element was 1, so that 1 is printed corresponding to this b0. Okay, and we'll see the next one, c equal to a. Here we are selecting the entire row because we have a column there before comma, and then what we are doing is we are selecting the second column. Okay, so the index is 1, that correspond to the second column. Okay, right. So again we are just printing that C, and we are just printing the shape also, right? Okay, so let's just run it. Yeah, right. So here we have the output, the second column, all rows. Okay, so our second column was 2 6 and 10. Okay, so here you can see uh, all the rows are selected but only the second column is selected. Okay, and here also the shape function. Okay, the c dot shape, that return the value 3 comma. Okay, so again that's a tuple, and since it's 1 by 3 array, we just get 3, right? And yeah, the c0. Okay, so that's the first element, we get the value as 2. Okay, so that's how you slice a numpy array. We can perform um, others also, like if you want to select more than one row or one column, or if you want to like have specific selections, right? So let's just see that we are just printing the array again so that we see what's happening. Okay, so ar underscore p in bracket a, so that prints the array. So the original array was 1 2 3 4 1 2 3 4 5 6 7 8 9 10 11 12. Okay, so now what we are doing here is, to b we are copying these values. Okay, so the row, it's 1 colon 3, so that starts from 1 index 1 to it goes to index 3. Okay, and we are selecting every column, okay, inside these rows. So what happened is we get 5 6 7 8, okay, because we started from the first row, not first row, from the index 1. Okay, so index 1 corresponds to the second row, right? So we start from, or the second row is selected, and we go up to index 2, right? When you're writing the number 3 here, then it goes to 2 only. Okay, so the index number 2, so that will be the last row there. So, and we are selecting the whole column, so what we get is 5 6 7 8 and 9 10 11 12. Okay, so the last two rows are selected. Okay, and then here let's see what's happening. So we are writing c equal to a, we are putting colon 2. Okay, so for the row identification, we are putting colon 2. So if you're just simply putting colon, that means it's starting from 0, okay, or starting from the beginning, go up to 2. Okay, so that will be the first row, the index 1 only. Okay, so whatever you are giving as a second digit, it doesn't include that, right? Okay, so here we can see, and let's see the column also before we go into the see the output. And we are writing 2 colon end. Okay, so that means start from the second column, or like start from the column with index 2 and go to the last one. Okay, so here start from beginning, go to index 2. Here start from index 2, go to the end. Okay, so that's the meaning. So let's see what happened here. So the array, original array is 1 2 3 4 etc. So the we are starting from the first row itself. Okay, so we are getting this 3 4 and we are getting this 7 8. Okay, so that two rows are taken, and then we are starting from the column with index 2 only. Okay, so the index 2 will be here, it will be 1, sorry, here the index will be 0, here the index will be 1, and here the index will be 2. Okay, so we are starting from this column 3 7 11, right? So we are starting from this column, we are going to the end of the columns. Okay, so that means we'll be including this column which starts with 4 also. Okay, so when we are printing that, we get this, the first two rows and the last two columns. Okay, so if you print the shape of C there, it should be a 2 by 2 matrix. Okay, so yeah, let's just go to the other functionalities of NumPy. So earlier in the previous lecture we had created a random array, but suppose we need to create a random array which is filled with integers. Okay, so in such case you call np.random, and previously we had used again dot random here, but instead here we have to use rand int, okay, or random integer. And then we are giving the number 20 here and the size equal to 10. Okay, so that what happens is we are creating random integers up to the digit 20. Okay, or the value or the integers will be from 0 to 20, and the size of the array will be 10. Okay, so we'll just see it one by one. Yeah, so here you can see there will be 10 elements in total, but all the values that will be under 20. Okay, or the range starts from 0 to 20. So we are selecting 10 random numbers, 10 random numbers between 0 and 20. Okay, and there is now in the array here, we can see that none of the elements are repeated, but it's not always the case. Sometimes we might get the integers repeated, because we are just selecting them randomly and not depending on any other conditions. Okay, so if I am if so the array here was 9 3 6 7 etc. So if I just run the code again, so I'm getting another random array. Okay, and here you can see the number 14 is repeated 3 times. Okay, and yeah, so now just we'll I think we'll have a single array, and then we'll run the rest of the code also. Okay, otherwise when the array keeps changing it might be a bit confusing, so we'll just run the whole code with a single array. Yeah, so these two lines are over. We are creating a random array of size 10, and then what we are doing is in numpy we have the function sort. Okay, and this sort has different arguments also. Those who studied programming before, you might have heard of yeah, bubble sort, merge sort, etc. Okay, so there are different sorting algorithms, and yeah, you can use it as an argument here if you want any specific algorithm to use. Okay, but for normal people that's not necessary, so we can just write numpy.sort, and we are giving the array which needs to be sorted. Okay, so this function sorts the array A and returns the value to B, and we are just printing the value here. Okay, so these two lines just sorted the array and we are printing the value. So here you can see the sorted array will be printed as 3 4 6 8 10 had come twice, so 10 10 12 15 16 17. Okay, and then uh, I mentioned in the previous video that numpy can perform whole lot of mathematical operations. Okay, so almost all possible mathematical operations that you can think of at your stage, most probably numpy have a function inbuilt for that. Okay, you don't have to write the code by yourself. So here, if you want to find the average of or mean of the elements of A, okay, what we do is we just write A dot mean. Okay, and A dot mean. So in this case, the A must be a numpy array. Okay, if the A was a list, this may not work. Okay, because this dot mean is implemented inside the numpy library. Okay, so we are storing that value to M, and then we are printing that. So here you can see the mean value is 10.1. Okay, the mean value of all the elements in this array, right? And suppose we need to get the sum of all the elements, then we simply write a dot sum, and we have the sum. Okay, so here we had actually 10 elements, so the sum will be the average times 10, so that's 10.1 into 10 only, so that's 101. Okay, and we can also get the maximum and the minimum values in the array, so that's simple as like writing a dot max and a dot min, right? So we get the maximum minimum and we are just printing it. And another great advantage with numpy is, suppose we want to add element 1 to all the elements in this array. Okay, so this array, not this array, the array named A, right? Sorry, yeah, this one only. Suppose this was our array, right? 4 6 10 6 12 15 etc. And suppose we need to add the value 1. Okay, or if you want to add 1 to all the elements. Okay, so if it was a list, we had to write a for loop and then take each element in the list, then add 1, then store it back to the list, etc. But in numpy it's straightforward. You just write a plus 1. Okay, so A was a list, and when numpy sees that it's a list, or not list exactly, it's an array, and when numpy sees that it's a numpy array, it just simply adds one to the, or add ones to the whole array, right? So the same thing can be repeated using subtract, multiplication, etc., or division, etc., right? Okay, so if you want to multiply each element with 2, you can simply write A into 2. Okay, so that's really one really good functionality about numpy. You don't have to loop to perform all these functions. Okay, and there are different metrics operations also available in numpy. So suppose we are creating a 3 by 3 array, matrix, or yeah, 1 2 3 4 5 6 7 8 9, and I want to create a identity matrix. Okay, so I hope you remember what identity matrix is. That's if it's a 3 by 3 identity matrix, we have 1 0 0 0 1 0, then 0 0 1. Okay, so this gives, okay, a into b actually gives a like element wise multiplication. Okay, that's different from your normal matrix multiplication. And if you need the matrix multiplication, what you have to do is you have to write a dot, then you have to write the word dot, and then b. Okay, so this only does the matrix multiplication. If you simply write a multiplied by b, that will be the element wise multiplication. That is, the corresponding elements will be multiplied and displayed. Okay, so we'll just see the result from both of them. Yeah, so our array was 1 2 3 4 5 6 7 8 9. That's a 3 by 3 array, and 3 by 3 matrix. So when you are doing the element wise multiplication, what happens is, for the identity matrix, except for the diagonal elements, all were 0, right? So when you are multiplying by corresponding elements, all the other terms become 0, but you have the diagonals here. Okay, so 1 5 and 9, the diagonals remain, all others become 0. And if you're multiplying, or if you're doing the matrix multiplication with the identity matrix, you know that the same array will be given back. Okay, so matrix A into identity matrix I will be equal to A. So here we get 1 2 3 4 5 6 7 8 9. Okay, so here we had started with a array that was integer, but after multiplication we are getting an array that is float. Okay, that's because this array b, okay, we created an identity matrix, but the problem is the default data type will be float only. Okay, so when you are multiplying integer with a float, we'll get a float back. Okay, so yeah, I hope that's clear. We'll just see one more function, so that will be the transpose. Okay, so if we had the elements, or matrix A with the elements we had seen before, so here we will just print the transpose of that array. So you can see that our initial array was 1 2 3 4 5 6 etc, but here we get the transpose. Okay, so the row became the column. So the transpose, the function was just dot t. The original matrix was A, then a dot a dot t gives the transpose of that matrix. Okay, so that will be about numpy array. There are many other functionalities of numpy array. So if you are interested, you can just look it up. Okay, so we'll stop the video for now. Thank you for watching.